This is section 1-4, Extrema and Average Rates of Change. Some of the vocabulary we're going to be looking at: increasing and decreasing functions, constant functions. We'll be looking at maximum and minimum value and what is meant by extrema. Now, the first thing we're going to talk about is increasing, decreasing, and constant functions. And it's pretty easy to tell when you look at these functions. You'll see in this first one, for an increasing function, as x gets larger, you can see that f of x, the height, will also get larger. So we can say, as x increases, f of x also increases. And you can tell from looking at that, you can kind of get a picture of what's happening. You're going to have a function that is increasing as you move from left to right. For a decreasing function, for this next one, you can see that as the function moves from left to right, you can see that the function height is actually falling. So we can say that as x increases, f of x decreases in value. And you can see that you have kind of a falling function when the function is decreasing. And for this last one, it's considered a constant function, at least on an interval, if as x increases, f of x remains the same. And you can see between x sub 1 and x sub 2, in between these two values, x is increasing, but look at the function height, it's remaining the same. So that's what's meant by increasing, decreasing, and constant functions, and how you can tell which is which. For this next problem, we are asked to use the graph of the function f of x equals x squared minus 4 to estimate intervals to the nearest 0.5 unit on which the function is increasing, decreasing, or constant, and then we're asked to support our answer numerically. Now, first of all, notice on this graph that it actually appears to be falling from, as we move from left to right, it appears to be falling from negative, when x is negative infinity, up until we get to about, well, we can see at 0. We can see at 0 it changes directions and becomes increasing. So we could say it's decreasing. The function is decreasing as x goes from negative infinity to 0. And then it's increasing as x goes from 0 to infinity. And that's how we can show just by looking at the graph. There's no place where it's actually constant, because if x is changing, then the height of my function is also changing. So again, it's decreasing as x goes from very small negative numbers up until 0. It is a decreasing function, and then it changes directions and becomes an increasing function. To show this numerically, or to support our answer numerically, take your calculator and you could type in your function, x squared minus 4, and I'm going to adjust my window the same way that my window is adjusted on the problem. It looks like it goes from negative 5 to 5 in the x direction and from negative 5 to 5 in the y direction. So if I actually graph this, then I can see I get the same picture that I have displayed on the PowerPoint. So now I want to set my, we're going to create a table to support our answer numerically. So I'm going to set my table to start at negative 5 to represent where it's starting on my graph. And I'm going to set my delta table to be 0.5 because they asked me to estimate intervals to the nearest 0.5 unit. Again, setting up your independent variable is auto, so your calculator will fill those in for you. And now if you go second table and take a look, you can see at negative 5 it was 21, so it was a very kind of a high value. And notice as x gets larger, we're starting we didn't start at negative infinity, but we're starting at the left side of our graph, and we're moving towards the right. And look what happens as x gets larger. Look what's happening in the column y1. You can see that those values are falling, and they continue to fall until we get, keep going here, until we get to 0, where we had a negative 4 for the height of the function. And now as we start increasing, as we continue to increase our values of x, notice what's happening to the values of y. Now they are actually increasing in value, and so now our function is increasing. So that's how you can show this, support your answer numerically. Now you don't have to copy this entire table just you can copy it, just a couple values that are on either side of 0. So just looking right here, we see that f of negative 0.5 is negative 3.75, which is a larger value than f of 0. So you can just report those three values, and that would be sufficient. Now, if we take a look at this example, our function f of x equals negative x cubed plus x. And again, we're trying to find the intervals where it's increasing, decreasing, or constant. So again, move from left to right. So you're always starting when x equals negative infinity, as long as the arrow is going towards negative infinity. So for our first one, I can see that it's decreasing. So I'm going to have decreasing, because as I move from left to right, I can see the function is falling. So from negative infinity, and then where does it stop? Well, it appears to be about negative 1/2. Then it looks like it's increasing up until I get to this spot right here, which looks like about positive 1/2. So it's increasing from negative 1/2 to positive 1/2. And then it's decreasing as we continue to move towards the right from x equals 1/2, and then we're moving towards the right, so x goes towards infinity. So it's again decreasing as x goes from 1/2 to positive infinity. So that would be how we would show that with a graph. To support my answer numerically, I'm going to do the same thing that we did before. So I put my function in here, left my window on the calculator the same, set my table set like I did before. So I started at negative 5 and went in increments of 1/2. So now if I look at my table, and I'm going to see that it is decreasing as I'm moving to the right until I get to negative 1/2, and then notice that it starts to increase again. So now it's increasing, and then when I get to 1/2, at 1/2 it was 0.375, and as I continue to move towards the right, now it's decreasing again. So you'd have to write down some values numerically from your table that would show those changes. Here's a problem for you to try, so go ahead and pause the video, read over it, and see which answer you think is correct, and then restart the video. You should have selected C. First of all, just looking at the wording, you know that it's decreasing. Hopefully, as you move from left to right, you see the function is falling, so it's decreasing, and then it begins to increase. So it seems to be changing at approximately -1. Now, obviously, it's not exactly -1, but to the nearest 0.5 unit, that's what it would be. The next thing I want to talk about are relative and absolute extrema. Extrema just means extreme values. So we're looking at the very highest points on a function and the lowest points on a function. Now the difference between a relative and an absolute, I'll use this as an example for maximums, and you could read over this kind of more mathematical language on the left side. But if you look at point A, and specifically the height at f of A, you'll see that we have a maximum. We call this a relative maximum because if you look at the points on either side of f of A, or on either side of A, you can see that the heights are a little lower. So relative to the points around it, f of A is a high point. If you look at B here, when x equals B, f of B is also a relative max because it is a maximum point relative to the points on either side. However, this particular value is also an absolute max because it is the absolute maximum value of the function over the entire function. Notice the arrows pointing down. There's no other point on this function that's higher than f of b, so that's an absolute max, whereas f of a is a relative max. Now down here we have some minimum values. F of a would be considered a relative minimum value, and f of b is also considered a relative minimum value because it's a minimum relative to the points on either side of it. However, this is also considered an absolute min because there's no other point on the function where there's a function value lower than that point. So it's an absolute minimum. Now in this case, notice we have a maximum somewhere between A and B. There is a function value, f of whatever that value is, and it's a relative max. But this is not an absolute max because this function continues to go up. If you look at the end behavior, the function continues to increase. So this is a relative max, but there is no absolute max for this function. Just like in this first function, even though this point right here would be a relative minimum value, there's no absolute minimum value because the arrows are pointing down and that function continues to decrease as x goes to infinity and as x goes to negative infinity. So if you look at this function and you want to find the type of extrema, it appears that we have a relative min, or minimum, I just abbreviate it, of, looks like we have a value of -8 at x equals, be careful that you look at the scale, because if this is -2, it looks like they're counting by 2s, then this would be approximately -1. So when x is approximately -1, it appears that we have a minimum value, a relative min, of -8. At we have a relative max of, it looks like, about 14 when x equals 2. So we have a relative min, we have a relative max. However, there is no absolute min and no absolute max because pay attention to the end behavior. Remember the limit as x approaches negative infinity of f of x equals infinity. So this described our end behavior that we did in the last section. The limit as x approaches infinity of f of x equals negative infinity. So this described our end behavior for this function. To support this numerically, you can actually type the function into your calculator. I set my window according to how the window was set here. So I went from -10 to 10 and scaled it by 2, -20 to 20 and scaled it by 4. Then that way when you look at the graph, you will actually see the same picture that you see on the PowerPoint or on this video. So now if I set my table set, I set it to start at -2, and I decided to do this one by whole number increments. So now if you look at your table to get some values, I can see on either side of the -1. So I thought that there was a relative min when x equals -1, and you can see on either side of the -1, the heights are higher. So that tells me that there was a minimum value approximately when x equals -1, because I can see the height was -7 and the heights on either side are larger than that. If you look at when x equals 2, that's where we said there was a maximum and we had a height of 14, and look on either side, we had a height of 3 and a height of -27, so you can see 14 is higher. So that's how you can show that, support your answer numerically. Go ahead and try this problem and see if you can come up with the correct answer. And then when you're ready to go on, pause it, and then when you know the answer, go on. From the graph, you should have been able to tell the correct answer is B. And if you have questions about that, you can ask me in class tomorrow. For this problem, we're using our graphing calculator, and we're going to estimate for this function where the relative or absolute extrema will occur. So the first thing you would do is type this function into your calculator. Then I actually did zoom 6 for a standard viewing window, and it gave me a pretty good picture. So I can tell that this function appears, first of all, there is no absolute max because I can see the end behavior is going up in both directions. However, it appears that I have a relative min and I have a relative max. It looks like maybe that happens about 0. And I have an absolute min. Now we can find those values with your calculator by going second, calc, and you'll notice you have min and max. So I'm going to choose min first. and it wants to know a left bound. Well, it looks like it happens at about -1 or -2, so I'm going to type in my left bound of -3 and put enter. And now I have to give it a right bound. So for my right bound, I'm going to put -1. And then it asks me to make a guess. So I'm going to guess -2, somewhere in between. And now it will tell me my minimum value. So I could write down that I have a minimum value. So we have, this would be a relative min at negative, we're supposed to go to the nearest hundredth, -1.47.80. Now keep in mind, this is the min. It occurs at this value of x, but the minimum value of the function is 0.8, and again, that would be the relative min. To find my relative max, I'm going to go second, calc, max, which is number 4, and put in a guess for the left bound. So I'm going to put in -1. For a right bound, I'm going to put in 1. And for a guess, I'm going to put in 0. And it appears that we have a relative max at -0.20, 4.20. And again, the max, if I was asked the relative maximum value, I would say 4.20. Then the last thing I need to do here is one more thing, second calc min, so number 3. Okay, that is my, clear that. So for my left bound, I'm going to guess a 1. For my right bound, I'm going to guess a 4. And for my guess, I'll put a 3. Uh-oh. No, it didn't. Oh, okay, guessing a 3. And I get a value here. Now this one, remember, is an absolute min. At 1.67, -5.51.